hope you've already looked at solving two unknowns by substitution, because now we're going to go and look at the program that will help you learn another method, which is called elimination. So let's go to Algebra 2 Unknowns, and just above substitution is elimination with two unknowns. This is actually the first program I ever wrote for algebra, and I think it can help you a lot if you follow along. I'm going to push begin up here, and what will happen is we'll get two independent equations that are consistent, and we're going to try to find the one x and one y that will make both of these equations true. And this method is called elimination or addition method. Sometimes it's called that. But when you say the word elimination, it sort of makes me think of the mafia or something, trying to eliminate somebody. So if you think about it that way, that's really what we're going to try to do. We're going to try to eliminate a variable, and we're going to use two things. We're going to use the fact that we can multiply an equation both sides by anything we want, and we can add things that are equal. If we have two things that are equal here and two things that are equal here, we add them together, we'll get something that's still equal. So I'm going to give you this scroll bar that moves from -10 to 10, and wherever you stop, look what I'm going to do for you. 3 multiplications. -10 times 7 is -70. -10 times 3 is -30. -10 times 22. This will automatically multiply this equation by any number you choose. Same with this scroll bar. It will multiply the second equation by any number you choose. So the only skill you have to get is what to multiply by so that we can eliminate somebody. Now, this is usually, takes a little while to get used to it, but if you concentrate on 7 and 2 and think of the same number that you used when you were a kid trying to find a common denominator, what's the smallest number that both 7 and 2 can divide into a whole number of times? I hope you thought of 14. If you did, that would be the magic number to eliminate x's. Now let's look at the y's. 3 and 1. What's the smallest number that 3 and 1 can both divide into a whole number of times? Well, it would be 3. So 3 would be the magic number to eliminate the y's. So let's attack the x's. We said the number would be 14. Now what we want to do is get a 14 here and a 14 here, but we want one of them to be positive and one of them to be negative so that they can kill each other off. So we're going to try to get a 14, so I don't need a 4, I need a 2. Now I've got a 14 here, and I need to get a 14 here, so I'll need a 7. But look, see, 7 doesn't do me any good because that's positive 14 and positive 14. They can't eliminate each other. I'm going to have to go and get a negative on one of these guys. So now when I multiply this way and I come over here, I see that I have 14x and minus 14x. So if I take these two equations and add them together, and I've given you a little add button to do all the tedious arithmetic for you while you learn the skill of what to multiply by. So I'll do the adding for you. You're going to have to do it for yourself on your homework. But look, that the 14x's eliminated each other because one was positive and one was negative, and now we have 6 and 7 makes 13. 44 and 21 makes 65. Now I have this true equation, but it only has one unknown, so I can solve it. 13y is equal to 65, so I need to see what would y be, so I have to divide both sides by 13. So I think it is 5. I'm going to come over here and go 5. Now, when we eliminated the x's, we found out what the y was. You could take that 5 and plug it back in here and go 2x minus 5 is equal to -3. And you might do that when you were working this by hand. But I want to show you When we matched up the x's, we found the y. If we match up the y's, we're going to find the x's. So we said the magic number here to eliminate y's would be 3. So I'm going to get this to 1 so that this stays 3. And I need to multiply this by 3. And now you see I have a positive 3y and a negative 3y. They're set up to eliminate each other when we add. And now we see that 13x is equal to 13. So x must be 1. And we check and we win. This is called elimination. Let's do one more problem. New problem. I hope by now you're starting to look at these numbers and say 7 and 3, I could turn them both into 21. 2 and 6, I could turn them both into 6. 21 and 6 are the target numbers, but we have to adjust them so one turns out to be positive and one turns out to be negative. And it really doesn't matter which one, just so one of them is positive and one of them is negative. So I'm going to get 21 here, so I'm going to multiply this by 3. Got negative 21, so I need this one to be positive 21, so I better multiply this by negative 7. The x's are set up to be eliminated. Let's kill them off. Boom, boom. Negative 32y is equal to 32, so y must be negative 1 halfway through. Now, we eliminated the x's and found the y. If we eliminate the y's, we need to get a 6 here. So to get a 6 here, I just have to multiply this by 1. And to get a 6 here, I need to multiply this by 3. And I check it. One was positive and one is negative. So they're ready to eliminate. I push the add button, and I get negative 16x is equal to negative 112. So let's see, I've got to think a little bit about 7. 6 is 4 is 2, 7. Yeah, it looks like it's 7. So x is 7. Check, we win. This is elimination. Sometimes students get a little antsy because once we teach elimination, they say, why did you bother teaching us substitution at all? The fact of the matter is that you need both of these techniques. There are two tools that you can use to solve equations. And when things get more complicated, sometimes you have to use substitution. But I agree with you. If it were only equations like this, I would choose elimination every time. But as a teacher, I have the responsibility of making sure you learn both methods. And if I were giving you a test, on a test I would give you maybe 20 problems, and I'd say work this problem by substitution, work this problem by elimination, work this problem by graphing. And then I would let you have your method of choice for a few of them. So make sure you learn all the methods for solving systems. If we didn't need them, we wouldn't try to teach them to you. So keep going. Let's learn. Thanks. Bye.